But welcome, everyone. Hopefully everyone's weekend was good. It's supposed to be a nice couple days, right? At least where I'm at. So hopefully it will be nice where you are. Oh, I don't know about you guys, but I don't really feel bad other than I have this really horrible headache, and I've had it for a couple days. It has this little tiny little cough, like it's not consistent, but I don't know. So I don't know if I have something sinus going on, or anybody have any of the same symptoms? Oh, that's not good, Amelia. Well, that's worse than having a headache. But the weird thing about my headache is that it won't go away if I take, usually Excedrin works for me. Tylenol doesn't really work so much for me, but even that's not working, so it's kind of strange. Usually my headache will go away, but anyway, I can deal with it. I'm here. So, like I talked about last time, there are a couple formula sheets I have for you guys for Unit 4, and they're not in doc sharing, sorry, that's from last year. It's under course materials is where we have it this year. But under course materials, you'll see towards at the very bottom, I think, is where they ended up loading a couple different formula sheets for Unit 4. And like I said last time, it seems like I was going to add a couple more on there last year, and then I'm not sure if I did or not. So if you see something that you think would be helpful, you know, as you go through Unit 4 that you don't see on that formula sheet, let me know and I can add that. Okay? Yeah, well, I wouldn't really say this a migraine material, but yes, I am glad that it's not, because I know that I have actually never had a migraine, but man, it really affects some people. You can't even function. So, those headaches. Ooh, that would be freaky, Amelia. I do have allergies, yeah. So I'm thinking that might be what it is. That hay fever. Ooh, I'm glad it's not that bad for me, Atiro, and I hope you don't get any soon, because that does not sound fun at all. And here is the link to the 4.02 quiz. There's number 4, there were a few questions on, and so if you look at your quiz and you find out that you had trouble on that particular question, check out that recording. I know some of you sent quiz corrections to me through Kmall, which is great. I'll add 0 points back that way too. But anyway, just another little recording in case you are having trouble with number 4. But what we're going to do today is try to, yeah, you know, some of those Illuminate recordings will ask you to type in your email. It doesn't actually have to be a real email. If you just make something up, that's what I do. Because we don't really track it or anything like that. It just gets you in. So, a little secret. I don't know if I should share with you guys, but I did. So, just type something. Yes, there you go. I like that one, Amelia. That's pretty funny. Use that one for Illuminate sessions if you are asked to type something in. But what we're going to do today is we're going to cover 4.04 through 4.07. If you've looked at the weekly schedule, that is all you have to get through this week. And then Friday starts your spring break. So if you get through these sooner, you can have your spring break sooner. That's fine with me. Or if you want to switch it up, I know a lot of you have friends or siblings that are on spring break this week, and if you want to hang on to these lessons and do them next week, that's fine too. So sometime this week, next week, get 4.04 through 4.07 done. Okay? Yes. There you go, Jiro. That's another good one. All right, so we're going to cover everything, and so that means on Wednesday you won't have a class connect because we're going to cover it all today. Okay? Yes, yes. So I'm trying to give you guys a little extra break there. All right, so we're going to talk about Wednesday, no class. Yep, Wednesday, no class. So I think I deleted it off of your class connect schedule already. Actually, that reminds me, I think I still might have something showing up on spring break week. We don't want to come to class on spring break week. Let me write myself a note. Cancel CC on spring break. We don't want to come. All right. But not on Wednesday either, so we won't meet till April after today. So happy Easter, because that will happen between now and then. Before I forget. So yeah, today we're going to talk about inscribed angles, central angles. We talked a little bit about that last time. Intercepted arcs, tangents, chords, arcs, secants, chord segments, tangent segments, a lot of stuff. But it sounds like probably more than it is. It's all related, and it's not too bad. This actually is just a review. And what I'm going to do, since I want to make sure we get through everything, so I'm just going to put the link at the bottom on the in the chat box. So if you guys we talked about this all last time, but if you're still kind of fuzzy, what's a major arc, what's a radius, what's a diameter, what's a semicircle, then check out this link or watch last week's Class Connects, because we talked about those last week. Let's see. Yes, that should be this Sunday, right? What do I have in there? Material. Let's see. Sorry, trying to get to my calendar here. Come on, computer. Yeah, the 27th. I think, do I have the 3rd in there? Okay, it does say the 27th? Yeah. Oh, okay. The end date should be the same. The due date might be different, but it won't close until March 27th. Because it was due last week, it was assigned last week. So the due date might say last week sometime. But you'll have till March 27th to get it in. Does that make sense? Yes, you still have time. Yep. Yes, if you guys are still finishing up the Unit 3 Part 2, you still have time. Okay. Oh, yeah, we're going to just skip that one, Material. I was just saying I'll put the link into the chat box. Part 2, yes. Not Part 2, yes, Part 2. All right, so here we're getting into Unit 4.04. It says, if radius BD bisects chord CE, what is the measure of angle BEA? So these are kind of fun, but at first they're tricky. So let's dissect the puzzle. So a few key words, you got to remember what bisect means. If BD bisects chord CE, that means that CA and AE are equal. And then it says, what is the measure of the angle BEA? So we're actually looking for this angle right here. Okay. There's something that you guys may or may not remember, but something that you should have learned about if there's a radius bisecting a chord. Anything you guys remember learning about the angles that get formed here? Good. That's the key thing that's going to help you on this question. It's going to be true if a radius bisects a chord. All 4 of those angles there are going to be right angles. Those are perpendicular lines. So Emma's got it now. She sees the triangle. So you have a little triangle that gets formed there, triangle BEA. I'll put it in green. And you know from the triangle, oh, my brain, my head, it's hurting. But the three angles in a triangle add up to 180, right? Oh, good, Emma. It's fresh in your mind, and it looks like you probably did a great job. So we have 180 minus that 90-degree angle that gets formed at angle BAE minus the 58-degree angle. That's going to leave us with angle, the measure of angle BEA. Oh, hold on, my dog is barking. I'm sure you can hear that. Hang on 1 second. All right, very good. So yep, it should work out to be 32 degrees if you type in 32. Oh, and by the way, since it's a a blank one, just type in 32, and that's it. You don't have to type in degrees. Check anytime they have one of those ones where you type it in on the quiz, go back and just double check and make sure it marked you correctly, because sometimes it is kind of funny on those pre-response ones, and it might mark you wrong when you're not. Oh, I'll have to get a picture of him, Material, and show him to you. Yeah, he is a small little dog, a toy poodle. Although he's a lot larger than he should be. He's a few pounds overweight, but he's a really, really sweet little dog. He is getting older though. Let's see, turned 10 in October. So anyway, you can tell he's getting older. He's no spring puppy anymore. Oh, do you, Emma? Yeah, we should. How about after the break? You guys should remind me. We should have a show your pet day. We could all take a picture of our pets and put them on the whiteboard. That would be fun. I don't, Atira. Actually, you know what? It's kind of funny. We don't even cut our dog's hair like a poodle cut. And so it's kind of funny because a lot of people come over and they'll say, what kind of dog is that? Just because we don't cut him like a poodle and he looks different. So we just kind of cut it all the same length. So I like it better like that. Ooh, I bet that lab husky's pretty. I like huskies. Well, there we go, Emma. We can do that. We can do that. There you go. 7 animals. Wow. So I bet you're busy feeding them all in the morning, right, Emma? Well, one of them's that puppy. Probably not a puppy anymore, huh? Okay, so not too bad. Fish is not too bad. Oh, he still is a puppy. Okay, well, good. I'm glad time's not going by too quickly. I agree, Cheryl. I don't like the poodle hairstyle. All right. Oh, okay. Yeah, I think this is a reminder to myself, too. Sometimes they want you to type the words in. So if you've taken the 4.04 quiz, check and make sure if you put in the number 32 that it didn't mark you wrong. And if it did, let me know. Send me a K-mail. I know, it is so weird. I don't know who writes these tests. Not me. I would take the answer 32. But anyway, yeah, double check and make sure it doesn't mark you guys wrong on that one. All right, question 2. According to the radius and chord theorem, DC is equal to what segment length? Okay, can anyone remind us, first of all, of what the radius and chord theorem says? Does anybody have that handy? It could even be a paraphrase. Okay, yep, you guys are right. CE is the answer. Okay, thanks for letting us know. So Emma said she typed in the number 32 for 32 and she got it right. Okay, so you could type the words in, but probably most of you guys won't. I mean, I wouldn't do that if I were you. Just type in the number 32. Okay, anybody remember what the radius and chord theorem says? If not, you might want to write it down. Oh, beautiful, Anthony, you got it. So he has it for us there in the chat. A radius that is perpendicular to a chord. So you can see that BA is a radius. It's perpendicular because it has the little box there. And it's the chord. Remember, a chord is just a segment that has its endpoints on a circle. So DE is a chord. It has its endpoint D and its endpoint E. So you would type CE in the blank. Okay. Now it should be capitals. I don't know for sure if it would mark you wrong if you did lowercase, but anytime you're naming a segment, it should be capitals, right? So we want to get into good habits. Okay, double check if you guys have taken it. Can you check and see if you put in CE, did it mark you wrong? Sometimes it'll, that's why I said I don't like when they do the free response because they always miss some of the correct answers somehow. So you could either do EC or CE E, because either one of those is a correct answer. Okay, so it did mark you correct for EC, right? All right, well, if you guys type in CE and it marks you incorrect, let me know, because CE or EC, those are both correct. Okay? All right, question 3. Now, this is multiple choice, so you should get there's only one possible choice here. It says if radius BE is perpendicular to a bisector, is a perpendicular bisector. Okay, so two things there. It means it's perpendicular and it cuts chord AC in half. Then what is AB to the nearest tenth? Anybody want to show us this one on the whiteboard? Did you guys figure this one out? It's kind of another puzzle. Once you see it, you'll probably say, oh, this is so easy. But if you don't see it, at first it's a little tricky. All right, Achiro, you are first to raise your hand, so go for it. So, yeah, sorry, Amelia, I just changed it. So yeah, if you guys are already, if you have the answer, put it into your polling tool, select A, B, C, or D up above, and see if you can beat Achiro. Doesn't mean Achiro is slow, but it takes some extra time to type out all that stuff on the whiteboard. But see if you can see it. Okay, so now a little bit more of the clue is getting filled in. Achiro is typing A squared plus B squared equals C squared. So if you're still like, I'm not quite seeing it, think about what A squared plus B squared equals C squared applies to. What sort of a shape? What sort of a shape does that formula apply to? And bonus point if you get the name of that theorem. What's the name of that theorem? What's it called? Okay, it applies to a triangle. Ooh, nice, Mata. Pythagorean theorem, and you spelled it correctly too. I love that. Very nice. Yep, so round of applause. Very nice, very nice. But yep, Achiro's looking at this triangle right here, triangle ADB. And he says, okay, I know that this segment here is 7, and I know because it bisects chord AC that AD and DC are going to be the same length, so they're both going to be 9. And we're looking for AB over here. So since this is a right triangle, I can apply Pythagorean theorem to that. Okay. Okay, now just for review, let's say you didn't have a calculator and you got it to this point. You know it, this would be a little bit tricky because they're all kind of in between 10 and 11. But probably most of you, or if you don't know it, you should know it. What's this square of 12? 12 times 12 is 144, right? And 10 squared is 100. So you know it has to be somewhere between 10 and 12. Now they were not nice to you. They gave you all numbers between 10 and 12. Okay? But you can kind of look at that and say, well, it's closer to 144 than it is to 100. So probably going with one of these higher numbers would be a better guess if you had to guess. But yes, if you have your calculator, put it in there, you get 11.4. Okay, any questions on that one? Do you guys see the puzzle now if you were a little stuck at the beginning? Yes, give it a round of applause. Very nice job. Beautiful. All right, slide 10. 4.04. Oh, this is the answer. Well, we already know the answer. Okay, slide 11, extra credit. Usually put this at the end, but I decided to put it in the middle today. So let me grab the link for you. There you go. There's your extra credit. Go ahead and take a screenshot of your score, put it in a Word doc, and attach the Word doc to the extra credit drop box. Okay? There you go. I like that, Achiro. You gonna try talking like him? Is that what you're saying? Yeah, you guys are probably really familiar with Mr. Thomas's voice now, right? All right, so let's keep moving. 4.06. Oh, gotcha. Ah, I got it now. Yeah, that's what you put the green check mark on there. Now I'm with you. Yes, there you go. Do it in Mr. Thomas style. All right, so 4.06, I have a couple pictures on the screen that are not inscribed angles. So this vertex of the angle is inside of the circle, and this vertex is outside of the circle. Neither one of those are called inscribed angles, okay? Yes, I was trying to emphasize the point there. Put a big thumbs down. This is not an inscribed angle. Inscribed angle is going to have an angle with its vertex on the circle. So this would be a picture of an inscribed angle because the vertex where the angle turns is on the edge of the circle. Okay? A central angle, we talked about central angles before. Those are not inscribed either. Remember, central angle, it kind of goes with the name. That's how it got its name, central angle, because the vertex is at the center of the circle. Okay? Let me put the link to the Brightstorm video up above, or I mean, the one that's up above, I'll put it in the chat. And then let's take a few minutes and just check this out real quick. All right, well, I guess we won't check that out real quick. Never mind. All right, well, I got to remember to take that out of the PowerPoint. I guess somehow they don't have that one anymore. Okay, well, we'll just go on our own. We'll have to figure this out without Brightstorm's help. Okay, so central angle, there's a couple formulas on the board that are important, okay? Oh, does it? Okay, well, if it works for you, watch it. If not, I will just explain it here. How's that? The measure of the central angle is equal to the intercepted arc measure. And we did talk about this one last time. So remember, the degree angle here is going to be the same as the measure of this arc. Okay? And that should be one of the formulas that's on the formula sheet for you. Yes, maybe that's the problem. Maybe that's it. The inscribed angle is half of the intercepted arc, or if you think of it vice versa, the intercepted arc is twice as much as the intercepted arc. So whatever the intercepted angle or the inscribed angle is, the intercepted arc is twice that much. Okay? Or if you know this number out here, let's say for example that this is 100, the inscribed angle is going to be 50, half that much. Okay? So it's either doubling it or having it, depending on which piece you have. So just be careful there. Think through it. Say, okay, if I have this number, I want to take half to get the inscribed angle. Or if I have the inscribed angle, I want to double it to find the intercepted arc. Okay, so just be careful there that you either take half or double it correctly. Just think through it. Okay, sure, let's see. I think I might have an example. Here we go, Anthony. Let's try this one out. So it says, what is the measure of an inscribed angle that intercepts an arc whose measure is 70? Okay, so let's label our picture over here. Where would this 70 go? So we want to know, what is the measure of an inscribed angle? And it intercepts an arc whose measure is 70. Yeah, so the arc is on the circle. So that is where the 70 goes. Okay, so we have 70 over here. Now you can think of it like this. If you like thinking through it with algebra, which I like you guys to do, you can say, well, 70 is equal to 2x. And I just want x, so if I use my algebra skills and I solve this for x, it's going to tell you what to do, and that's going to be taking half of 70. Okay, so you can set it up like a little algebra equation. Or just think through it and say, okay, well, the intercepted arc is always going to be the larger number. So if I double this, 140, it's not going to make sense. That wouldn't make sense for this to be 140 and for this to be 70. So that would tell you, oops, I went the wrong way. I actually want to take half of that, not double it. So you take, oh, okay, 70, half of that's 35. That would make sense because now if this is 35, it's smaller than the arc out here. Okay, so you can use algebra or just think through it because that inscribed angle should always be smaller than the arc on the edge of the circle. Does that make sense? Another important thing there are, it's knowing your vocabulary. So remember the inscribed angle is this angle right here. Okay, so just be careful with your vocabulary. All right, let's try another. So in triangle, ARC, the measure of angle A is 70. What is the measure of arc, AC? Okay, so, nice tip, Emma, I like that. If it's in, it has to be inside the circle, right? In center means it's going to be in the circle. Yep, that's obvious, but very good to notice. Yes. Okay, so this question's a little tricky. It's going to take some work to get there. It's not obvious. What are some things you guys notice about this picture? Anything that you see that might help us dissect this problem? Okay, yes, definitely noting the triangle is very important. Okay, how does the 30 and the 30 help you? So this side is 30 centimeters and this side's 30 centimeters. Okay, yep, that's true too. Emma's not a right triangle. Yeah, it's an isosceles triangle. So remember, if both of these sides are equal, what does that tell you about the base angles, angle RAC and RCA? Good, Mada's got it. So if this angle is 70, this one's also going to be 70. The two angles down there are the same. There, now Atiro's got it. So we can use the triangle sum theorem to figure out this lost angle up here, triangle ARC. Good. 70 and 70 adds up to 140. Then there's 40 degrees left to get to 180. So this angle here has to be 40 degrees. And how does that help you with arc AC? Good. If you double it, how did you know to double it? Atiro, what is the name of angle ARC? What kind of angle is that? It is inscribed. Well, that is true too, Atiro, yes. Good. So some of you guys saw it. Since this angle right here has a vertex on the edge of the circle, it's an inscribed angle. And the relationship is if you're looking for the arc that contains its endpoints of A and C, you're going to double this to get over here. So 80. Yep. There you go. Put that green check mark on there. Yep. So 40 times 2 is 80. Does everybody see that relationship between the inscribed angle and the arc? Any questions about how we got 80? Good. See, so once you guys started to see it, you're like, oh yeah, it's not so hard. But how many of you guys, raise your hand, be honest, how many of you read that at first and you looked at the picture and like, I do not know. I have no idea how to start on this one. Anybody really confused? Well, good, good. That's good. At least having the vote of confidence, like, okay, I might not know the answer right off the bat, but I can figure this out. That's awesome. Very good. Oh, and by the way, if you notice the title of this slide, this is mid-unit test review, so that could be a possible mid-unit test question you will get, okay? All right, 4.07. The converse of that theorem is also true, or the converse of this theorem, I should say, is true. So this is the theorem, an angle that is inscribed in a semicircle. So that means the endpoints are on the semicircle is a right angle. Okay, so here is your inscribed angle because the vertex of that angle is on the edge of the circle, and the endpoints are on the edge of the semicircle. So that's what this part means. Inscribed in a semicircle means that the endpoints are on the edges of the diameter, basically, the endpoints of the diameter, and this angle here is going to be 90. Okay? Oh, I like that, Emma. That's a good observation. Yeah, you do know where you could show that this is going to be an isosceles triangle. So you could figure out that those are going to be 45 and 45. Yeah, I like that. But the converse of this is also true. So if an inscribed angle is a right angle, then you know it's an intercepted, the intercepted arc is a semicircle. So it goes both ways. I know converse has been a little while ago, but converse, remember how you switch the P and the Q around, and that's also true in this case. Okay, now this picture gets a little more complicated. Two inscribed angles that intersect the same arc have the same measure. Makes sense, right, if you think about it. But here's what the picture looks like. So angle ADB is an inscribed angle because the vertex is on the edge of the circle, its endpoints are on the edges of the circle. Same thing for angle AEB. So they have to be the same because see how they both go between points A and B? Okay. Does that make sense what that one's saying? Okay, perfect, perfect. All right, let's keep going. We have 2 more slides and we have 5 minutes. I think we can do it. Another mid-unit test question. It says segments GT and GN are both tangent to circle A. What does that mean? Can you guys tell me what tangent, if lines are tangent to the circle, what does that mean? Yep, they intersect the circle at exactly 1 point. Good. So segment GT is touching the circle exactly at T. What else do you know? Good. You also know it's perpendicular to the radius. So notice how we have AT is the radius of the circle. We know that you're going to have a right angle here and a right angle over here because both GT and GN are tangent to circle A. Okay. If the measure of angle G is 35 degrees, so this angle right here is 35 degrees. Sorry. What is the measure of angle TAN? Here's a big hint over here. Anybody see a polygon in this picture? Can you guys point to it with your pointer hand? Okay, go around the edge of it. If you're just going in the middle of it, that's not very clear. Trace the polygon for me. There, that looks better. So we have polygon TANG, right? Polygon tang. Okay? So the hint, and that's from semester 1, so I wasn't sure if you'd remember or not, but the you got it. That's where that comes from. Good observation there, Emma. Yeah, they're starting to spell it tangent. Cool. So the interior angles in a polygon sum to 360. Can anybody show me on the board how we would figure out angle TAN? Knowing that fact? if the interior angles in a polygon sum to 360? Or more than one of you can go. All right, Anthony's going to go for it. Nice, nice. Oh, good. Nathaniel's typing it in the chat. That works too. But if you guys want to write it on the whiteboard, go for it. Anthony's going to do it for us. You're missing, wait, 1 sec, Anthony. You're totally on the right track. You're missing one angle in there. You have 90 and 90. Yeah, you want the 35-degree angle in there. But you are totally on the right track. And I love that you set it up as an algebra problem. That is awesome. It's much easier to do it that way. Very good. Give Anthony a round of applause. Beautiful. Yep. 145. So don't forget that as this one was tricky. It almost looked like a triangle, but it wasn't. This wasn't a straight line here between T and N, so it's not a triangle. It's actually, got to use this fact that it's a polygon. All right, last one. It says in circle O, the measure of angle ROW is 115. What kind of an angle is ROW? Okay, that is true, Amelia. In relation to circles that we talked about today, not inscribed, the vertex is at the center of the circle. So what kind of an angle is it called? There you go, central angle. Do you remember what is the relationship between the measure of the central angle and the arc? So if its angle right here is 115, yeah, it equals the arc. So that means arc RW is also 115 degrees. We're looking for the inscribed angle, which is RAW. Oh, no, actually, we're looking for arc RAW. Ooh, this is a little tricky. Okay, so how you can actually get it from what we have so far. How would we find arc RAW? Remember R, if it uses 3 letters, it's actually wanting the larger part of the circle. So you're going from R to A to W. How would we figure that out? Yes, the major arc. There you go, Nathaniel. Yeah, you know that there are 360 degrees in a circle. So if we take away the 115 that are in the part of the arc we don't need. Yes, so that was kind of tricky, Atiro. It didn't want, if it said if it had asked for angle, RAW would be right. The angle there would be 57.5 because you would take half of 115 to find that inscribed angle. but because it wanted the arc, you would actually go with answer C here. Ah, it's kind of tricky, huh? Does that make sense to everybody now, though? Do you guys see how you would get C? Yeah, go for it, Anthony. Let me know if you have questions. But if that makes sense to you guys, I know we're 3 minutes over, but we got through everything that we needed to, so no Class Connect Wednesday. Enjoy your spring break. Have a wonderful Easter, and I will see you guys in April.